Welcome. In this video series, we are going to look at rational expressions and rational equations, and then do operations with them in order to solve equations. So that's kind of our ultimate goal. Let's dig in. As we look at rational expressions, they are defined simply as anything that's of the form p over q, right? Where p and q are polynomials and q is not zero. I want to point out that we use the phrase polynomial. So that means something very specific. It has variables in it, right? And so we are going to be working with variables in the context of fractions, okay? And we can do hard things. Yes, this is going to be okay, all right? But if you need a friend to hold your hand as we go through this, that is fine, okay? Examples, okay? So things that are polynomials are actually our fraction numbers that we know, like 3 over 8. 3 is a polynomial, 8 is a polynomial. We can also see things like x over x plus 1. Let's see, 3x squared plus 2 over x to the 5th minus plus 5, x minus 5, right? Anything like that where we can do polynomial over polynomial, we're going to be good. Something that isn't going to be a rational expression, anything with a radical in it, yeah? And also we know that polynomials have to have positive exponents. So even if we had like x plus 1 in the numerator, if we had something like x to the minus 1 plus 2, right, that is not going to be a polynomial because that exponent has to be 0 or larger and a whole number. So there we go, okay? So just now that we have common language of, what is and is not an example here, when we work with fractions, we have to remember that the denominator can't be 0, right? So that's where this notion of undefined values comes into place. So we need to look for undefined values, note them, and then make sure in our work we're aware of them. Okay, so for each of these, right, we take the denominator, that's where we're looking for undefined values, and note that it cannot be 0. So I'm just going to take that and rewrite that as 3n plus 1 cannot be 0. And then I know how to solve this, right? So subtract 1, and I'm going to come up here, and I have 3n cannot be 1, and then divide by 3 to get a coefficient of 1, and I get n cannot be 1/3. So that 1/3 is our undefined value. Okay, so truthfully, I don't care if you have equals or not equals there, just find it. Okay, next up, this one. Okay, so we need to make sure that the denominator there is not 0, but that looks familiar to me. How do I solve that thing? So I can use the quadratic formula, right? We have that in our arsenal. Otherwise, I do have another favorite F word in math, factor. And then if I factor this, this would be a plus 3. A plus 1 cannot be 0. And then I would solve it using the zero product property. So coming over here, just so I have a little bit more space, a plus 3 cannot be 0, and a plus 1 cannot be 0. Okay, so then solve it. A cannot be negative 3, right? Subtract 3 from both sides, subtract 1 from both sides. A cannot be negative 1. Okay, so it is possible to get more than one undefined value per rational expression. Okay, and then once we find those undefined values, then we can simplify. Technically, if we simplify before, you're breaking math, potentially, so we just want to always define the undefined values first. Okay, and actually to simplify it is actually easier to do once we factor it. Okay, because for example, the numerator here looks like a hot mess, but I'm going to pull out a 5 first. If I do that, I get x squared minus 6xy plus 5y squared. Okay, and the denominator, if I pull out a 2, that's going to be x squared minus 25y squared. Okay, now I need to muster all my factoring skills that I have. And let's see, the numerator, if the y's weren't there, it would look like x minus 5, x minus 1, right? But the y is there, so actually this has to be a y and this has to be a 5y, and I think that's how it factors. You're welcome to FOIL it out, and I'm going to tell you it does factor like that. Denominator 2, and then x minus 5. Again, if the y squared wasn't there, it'd be x minus 5, x plus 5, and then the y's are needed to get to the y squared. Okay, and yes, you can see things that cancel. Don't do it. It's a trap. Okay, we need to just note undefined values. So from the first one, right, x can't be equal to 5y, and then x from the second one, if we set that equal to 0 and solve, we'd get x cannot be negative 5y. Now, what is y? It's kind of a little redundant, but we're just going to leave this off to the side. With that noted, with our undefined values noted, we're going to reduce anything that's common between the numerator and denominator. So I see this is common between both. So then I can say that this all simplifies to 5x minus y in parentheses over 2x plus 5y. And I can't cross out the x's, right? I need a whole factor in common, right? There's an x common among, part of these, but not everything, okay? So we have to just leave this as is, and we are done. All right, there you go. So again, rational expressions, fractions with algebraic expressions in them, we're going to be just fine, okay? Make sure to find undefined values. Make sure to factor in order to simplify.